Hello and good afternoon friends, welcome to CEC live lecture. Dear friends, today in this session we are going to talk on operating systems, and for this discussion we have once again with us in our studios Dr. Pavitra Bharadwaj. Dr. Bharadwaj is Assistant Professor in Department of Computer Sciences. She is teaching in Jesus and Mary College, University of Delhi. Dear friends, if you want to ask questions from Dr. Pavitra Bharadwaj on operating systems, then you can call us and you can contact us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. Dear friends, let's welcome our guest Dr. Pavitra Bharadwaj, and let's try to have a deep insight into the topic operating systems. Hello ma'am, welcome to the lecture.
Hello friends, today we are going to talk about a very interesting and vital topic in the field of computer science, that is operating systems. Now we all have come across this word since the very inception of our education in the field of computer science. Basically, in this lecture we are going to do the basics of operating system, as in what is an operating system, what are the basic functions of operating system, how have the operating systems evolved over time, and also some advanced topics like interrupts as the time permits. So basically we all understand that a computer system is composed of several components, like we have the hardware, we have the software, we have the users and the data. Now, hardware are all tangible parts of the computer, like the keyboard, the mouse, the RAM, the processor, which are the physical components of the computer. The software are the programs which are run on the computer. These are the logical components of the computer which are intangible in nature. Then we have the users. The users are basically the people or the other computers which are accessing the services of a particular computer, and then we have the data. Data is the main resource on which the computer is going to work. Now, operating system actually is a specific kind of software. When we say software, we mean a set of programs. Now, a set of programs could do various functions. For example, there are some softwares which are required by the user to perform his or her applications. For example, we have softwares like payroll software, we have banking software, we have a word processing software, we have spreadsheet applications, we have the internet browsers and all sorts of softwares. So these are basically the application softwares which are used by the user for his or her own requirements. But besides this also, there are other softwares which are required for the working of the system itself. These softwares are known as system softwares. So we can say that we have two types of softwares. One is the application software and second is the system software. So system softwares are classified as utility softwares and operating system. So we say that operating system is a type of system software. It is a software which is required for the functioning of the computer system itself. Now, if we see another diagram, we see how the operating system is placed in the computer system itself. Now, this diagram shows the hardware, which is the innermost circle. Then we have the operating system just outside the hardware. Then we have the utilities programs. On top of that, we have the application programs, and then we have the users. So basically what we see is that the users use the hardware of the computer but they do not use it directly. The hardware of the computer has a layer of operating system over it. On the operating system, there are utility programs which give access to the application softwares through which the user is connected. So, the operating system basically is providing an interface between the application programs and the computer's basic hardware. So, we say that a computer system can be divided into 4 components: hardware, which are the basic computing resources like CPU, memory, input-output devices, etc. Then we have the operating system, whose job is to control and coordinate the use of hardware among various applications and users. Then we have the application programs, which define the way in which the system resources are used to solve the computing problems of the users, like word processors, compilers, browsers, database systems, games, etc. And then of course we have the users, which are the people, machines or other computers which use the computer system. Now this diagram basically shows a layered view of the computer system. In this again we see that the computer hardware is superimposed by the operating system. The operating system encapsulates the hardware in a way that it can be operated, the hardware can be accessed and operated by the user's programs. So, the operating system provides an interface through which the system and application programs can run. System programs means the other system programs other than the operating system itself, like the device drivers and the compilers, etc. And then of course, these are provided with a program interface which provide the human interface for the users of the computer to interact with the hardware. So, we see that the basic hardware like the tape or the disk is accessed through hardware interface or privileged instructions of the operating system. Then we have the operating system, which provides an operating system interface to the user's program, and then we have the program interface, which provides an interface to the user. So, we have 3 layers of components within a computer system, and each layer has its own set of interface to interact with the layer above it. Like hardware has an hardware layer interface, then we have the program interface, and then we have the user's interface, which is provided by the operating system itself. Now, what we were discussing is the static view or static approach towards the components of the computer system. But when we talk about the dynamic approach, what we are saying is how actually a program which is asked by the user, which is run by the user, is executed by the computer software. So, this is depicted by the dynamic approach of the system component. So, in the dynamic view of the system components, we can see that a user provides an input to the application software. The application software puts through the service request to the operating system, which in turn gives instructions to the computer hardware to execute the request given by the user. After the request is processed, the results are sent back from the computer hardware to the operating system, from which they travel back to the application software in the form of service response, and the application software in turn gives the result as the output to the user. So, while the instructions are executed in the computer, there is a transfer of data in the form of input and information in the form of output, which takes place from user to application program, from application program to the operating system, from operating system to the hardware. and once the process is complete, the request has been processed, then the flow is in the opposite direction, that is from the hardware to the operating system, from the operating system to the application program, and from the application program the data travels back to the user. Therefore, we see that an operating system is the most important vital link between the user and the hardware of the computer. It will only be possible to run the programs on the hardware if we are provided with this interface of the operating system. So, basically, after this introduction, we should be able to understand what is an operating system. So, when we talk about operating system, there is no universally accepted definition, but we can say that it acts as an interface between the application program and the machine's hardware. It is the software that enables all the programs we use. It is the one program which is running at all times on the computers. It is known as the kernel. Everything else is the system program, which is a part of the operating system only, or an application program. So, the operating system organizes and controls the hardware, that is the CPU, the RAM, the input output. It takes care of the security of the system, it takes care of the system's interface and also the application interface of the program. So, what we are talking about is the kernel view of the operating system. So, we mean by a kernel that a program which is running at all the times when the computer is running. It is important to understand that all the other programs may start and stop, but kernel is one program which always resides in the memory while the computer is on. So, in this diagram we can see that we have devices in the lowermost layer which provides the interrupts to the operating system kernel, and we have processes which also approach the operating system kernel through a system call, or maybe there is a page fault. Whatever interaction of the devices and the processes is taking place, it is basically taking place through the kernel of the operating system. We can say that the kernel is actually the core of the operating system. Besides the kernel also there are programs in the operating system, there are other system programs also, but the most important program which always keeps running is the operating system kernel. So, some of the operating systems which are commonly used are Linux, Unix, Windows, IBM OS, and there are several other operating systems, right. So, this diagram also shows how an operating system helps the user run his or her application on the basic hardware and to access the hardware to perform his or her own jobs on the computer system. Now, basically what are the objectives of an operating system? The objective of an operating system is to make the system convenient and easy to use for the user. Loading a program into the memory, using the input-output devices. So, to use the hardware in an efficient way, supervise and manage the hardware, managing the communication between different devices, and controlling the sequence and execution of processes. Of course, this list is not a comprehensive list, as we will see that the functions performed by an operating system are much large and much varied than what we see in this list. But these are the basic objectives of an operating system, that is file management, security management, device management, resource management, etc. Now, what does an operating system do actually? It depends from user to user, from a system to another, that what is the role of an operating system. Basically what we are saying is that the user wants ease of use and good performance. the resource utilization is never a priority for a computer user. But in case of shared computers such as mainframe or mini computers where we have a client server architecture, the operating system not just takes care of one user but has to look after the needs of all the other users. Now, users of dedicated systems such as workstations have dedicated resources, but even these users sometimes access resources from the servers. Then we have other types of computers like handheld computers where resources are poor and these computers are optimized for usability and battery life and portability. So, in this case the operating system's roles change because the resources are very limited. And there are some other computers like the embedded computers, which we are also called embedded systems, which have little or no user interface, like the computers which are coming embedded in various devices like microwave ovens or washing machines or all automatic devices. So, basically what we are saying is that depending upon the requirement of a computer system, the operating system has its roles to play. The role that an operating system will play in a shared multi-user environment will be very different from an operating system which is working on a handheld device, maybe a mobile phone, or maybe an embedded system will be having little or no user interface, whereas a single user computer may be having a very rich graphical user interface. Therefore, the job of an operating system will depend on the architecture of a system which is being used for it. So, now we are going to come to the main functions of an operating system. So, the main functions of an operating system, as we can see here, are process management, user interface, protection and security, device management, file management and memory management. These are some very important 6 very basic functions which all operating systems will perform irrespective of the environment in which they are working. So, the first function that we take up is process management. But before we start with process management, we need to understand what exactly a process is. So, basically what is a process? A process is a program in execution. We can say that a program is a passive unit, whereas the process is its active unit. So, an operating system controls the access to shared resources like file, memory, input output and CPU. It controls the execution of applications. It creates, executes and deletes a process. It can cancel or resume a process, and it schedules a process using CPU scheduling, which we will be discussing. Its job is also to synchronize, communicate and handle all deadlocks which are occurring in case of processes. So, basically what we are saying is that a process is an active unit of a program. So, the job of a process of the operating system is basically to initiate a process and to see that the process runs to execution. Once the process is executing, it may be stopped for an input output request. Once the process is stopped for input output request, it goes in the wait stage. After it is in the wait stage, or when it is in the wait stage, the operating system will grant the CPU to another process. So, basically the CPU is never left idle, and this is the job of an operating system, to see that the CPU is always kept busy. It is never left idle. So, for this, the CPU scheduling becomes a very critical job of the operating system. Now what do we mean by CPU scheduling? In brief, we will see CPU scheduling means granting the CPU to the active processes of the computer which are going on. For example, we have different algorithms to see that which process gets the CPU. These algorithms are all non-preemptive algorithms. Non-preemptive means that the process does not have the right to interrupt the CPU. It will have to wait for its turn. But how the CPU is granted to a particular process will be ascertained by any of the three algorithms. So the first CPU algorithm which is generally used is first in, first out. That is a queue based algorithm. The process which comes first will be given the CPU first, and the process which comes next will be given the CPU next. The second type of CPU scheduling algorithm is last in, first out. That is, the process to come last in the queue is the first to get the CPU. And there is another algorithm which is the round robin algorithm, in which the CPU's time is sliced between the different active processes, and each process gets a slice of the time of the CPU. So all this scheduling of the CPU is done by the operating system. Besides this, there could be a state called deadlock. Now deadlock is a state where we have two or more than two active processes which are competing for a common resource, which could be a hardware resource, which could be a CPU, or which could be a data resource. Now deadlock is a very interesting phenomenon which occurs in case of computers. Deadlocks generally occur when all of the following four conditions are true. Now what are these conditions? They are mutual exclusion, hold and wait, circular wait, and no preemption. What is mutual exclusion? In case of mutual exclusion, the processes have a requirement that the resource that they are taking will not be given to any other resource. That is, the process has a complete right or an exclusive right over a particular resource. The condition of hold and wait will occur when a process is holding one resource and is waiting for the other resource which is being held by another resource. So in this way, this process is waiting for a resource while it is holding another resource with it, and which resource could be required by any other active process. So it is not utilizing a resource which it has got, in fact it is waiting for another. So we say that it is holding on to a resource and waiting for another resource, therefore not utilizing any of the resources efficiently. Then the other condition for a deadlock is circular wait. Circular wait means that one process is waiting for a resource which is held by another process, which in turn is waiting for a process or a resource which is held by a third process. So in this way there is a circular wait. Each process is waiting for a resource which is held by another process, and therefore none of the processes are able to move forward or be executed. Then there is another condition for a deadlock, which is no preemption. There are some processes which will not allow to be preempted or interrupted in between. So if that process is taking too long a time of the CPU, even then the CPU will be allocated or will be given to this process, and all other processes will keep on waiting till the time this particular process releases the CPU. Therefore, what we are saying is that the operating system's job is to give the CPU, to schedule the CPU so that all the processes keep on running, and the situation of a deadlock is averted. The best strategy to meet deadlock is deadlock avoidance. That is to create a situation where all the 4 of the conditions are never true. They are never happening. So, one of the major important functions of the operating system, that is process management, involves all these 3: to start a process, to delete or end or terminate a process, to shift a process from running state to waiting state, to schedule the time of the CPU between all the running processes, and to avoid or to deal with the situation of deadlocks where an endless wait is occurring between the different processes. The next important function of this operating system is memory management. Now, memory management means how the CPU allocates the memory to the different resources or to the different processes. Now, memory allocation can be done through multiple partition allocation or through paging. Then the job of the operating system is also to free the memory, to reallocate the memory, to keep track of memory usage by different processes, and also an important aspect of memory management is the virtual memory management. So, the first point that we see is multiple partition allocation. So, in case of multiple partition allocation, the memory is supposed to be composed of several holes, and whenever a process asks for a memory, demands for a memory, a hole is given to it. Therefore, the pool of holes is created which returns back when the process is complete. The memory is returned back to the pool of processes. But because of this, a common problem of fragmentation occurs, because the holes which are given to the processes, they are given according to 3 algorithms, that is first fit, worst fit and best fit. So, according to the first fit algorithm, a hole which is the first in the queue is given to a process or to a file which is asking for it. Whether it is of the appropriate size, whether it is big or small, a hole is given to a process. According to worst hit, a hole which is of the largest size is given to a process which is demanding it, and according to the best fit algorithm, the hole is given which is the best possible fit according to the demand of the process. But all of these 3 algorithms, they lead to creation of fragmentation. Fragmentation means that a large number of blank holes will be there, a large number of vacant memory positions will be there, but they are fragmented or they are lying scattered in the memory. So, practically even if a large space of the memory is empty, still sometimes it will be observed that a process will not get enough memory space because of fragmentation. So, the job of the operating system is to reduce this effort of fragmentation. Thus, to mitigate this, we have another algorithm which deals with the memory management through paging. So, paging is a technique for memory allocation by the operating system, in which frames are created in the physical memory and pages are created in the logical memory, and a table called the page table is maintained, which keeps a track of which frame is being allocated to which page. Therefore, in this case, a suitable mapping between the frames and the pages always occurs. Thus, paging will always be helpful in solving the problem of fragmentation. However, paging also has the problems of overheads, because sometimes managing the page table is in itself a very tedious task for the operating system. Nevertheless, paging is used as a solution or as an alternative to memory allocation, which is done through multiple partition allocation. Then the operating system also frees the memory from the processes which do not require it. Then it also allocates the memory which is freed from the other processes to the processes which require it. So a block of memory which is freed from a process is quickly allocated to another block of the process or CPU which is asking for it. This is known as memory reallocation. Then an important aspect of the CPU memory management function is to keep track of the memory usage. It always keeps a track of which process is using memory, how much of the memory is being used by the process. And there is virtual memory. So the management of virtual memory we will continue shortly. Thank you. Welcome back. So we were discussing the concept of memory management by the operating system. In this regard, we have a very important function of virtual memory. Now what is virtual memory? The term virtual means not real. So when we are saying virtual memory, we mean it is the memory which is not actually the primary memory, but it is a portion of the computer's secondary memory or the hard disk which actually functions like the primary memory. Because we understand that there are sometimes processes which are too big to reside in the main memory. We say that all processes which are being executed are present in the main memory. But we also understand that the size of the main memory may not be sufficient to hold the processes, because a large number of processes or multiple processes may be working at the same time in case of a multi-programming or a multitasking computer. So what is the solution to this? The solution to this is to create a space in the hard disk which will act as a buffer space for the RAM, so that data can be, which is required by the CPU, can be placed in this portion of the hard disk and it can be brought in to the RAM as and when required by the CPU. So this type of arrangement is known as a virtual memory. So virtual memory is basically a portion of the hard disk which behaves like the primary memory or the RAM of the computer. So it allows the execution of those programs which are not completely in the computer's memory. It is implemented through demand paging. Now, what is the concept of demand paging? Basically, we have understood what is paging. Demand paging is also implemented as paging with swapping. The process resides in the online secondary storage, and when the page is required by a process, that page is swapped into the main memory. It allows the execution of large size programs without loading them into the main memory. Now, what is the concept of demand paging? Very briefly, I can explain that we are saying that the logical memory has partitions which are called as pages. Now, the portions of a process reside in the main memory in the form of pages, whereas on the hard disk the other portions of the same process are residing. Now, when a CPU asks for a particular page, the page is present in the main memory, it is brought into the CPU. But if the page is not present in the memory, then it is brought in from the secondary storage device, and a page which is present in the main memory is replaced and put back into the secondary storage device. So, this is continuously happening, where one page from the secondary memory is brought into the primary memory, and that from the primary memory is sent back to the secondary memory. So, this diagram here represents how the virtual memory is working. So, we see that the disk has several pages and a page is swapped in to the memory. The data or program instructions which are most recently from the disk to the memory, they reside on top of the virtual memory, and the data and program instructions which are least recently used in the memory, they are swapped out. There is a principle of locality of reference which is used in it, and also several algorithms are used like last in first out or first in first out, and several other algorithms which are used for determining that which pages are to be swapped out and which pages will remain. Another important algorithm is the least recently used algorithm, which will replace the page from the main memory which was not used recently or until late. But again, it is important to note here that this also involves some overheads, but the operating system will see to it that the correct pages reside in the main memory, and it is very less that a page fault will occur. A page fault occurs when a page which is asked by the CPU is not present in the memory and has to be brought from the disk. Now, another important function of this operating system besides process and file memory management is the file management. Now, basically what is a file? A file consists of handling of related information which has a name, and it is stored on a secondary storage device. A file could be a sequential access file or a direct access file. Now, the file management also involves the management of the directory structure. Directory structure means the arrangement of all the folders and directories in the computer to locate any file promptly. As we all are aware that we have a hierarchical or a tree-like structure when we access files in the commonly used Windows operating system. So, each operating system has its own way of managing its files and its file directory systems. Even the file names are dependent on the operating systems. Some operating systems provide one set of rules for defining the names and sizes of the files. Other operating systems, they have their own rules. Therefore, files are completely dependent, file management is completely dependent on the operating system which is being used in the computer system. One more important function is device management. Device management. Now, what are devices? Devices are the peripheral devices which are connected to a computer. So, operating system handles the devices by combining both hardware and software techniques. The input-output hardware ports includes ports, buses, device controllers for the devices. The operating system communicates with the device via the device driver. Input-output scheduling, buffering and spooling is also done by the operating system. Buffer memory areas are the areas that store data while it is being transferred between two devices or an application and a device. Spooling is basically referring to putting the data in an area, in a buffer area in a memory or disk. Spooling stands for simultaneous peripheral operations online. So, what we are saying here is that in case of devices, there is a device driver which comes along with the device. This is a software which is installed when the device is connected to a computer. For instance, if you put any new device, if you add any new peripheral to your computer, you need to install the device driver or the software for that particular device. Besides this, there is a device controller which is a part of the device's hardware which communicates to the device driver, and the device driver in turn communicates with the operating system. Now, the devices, they use different techniques like spooling. Now, what is spooling? We all have observed that in case of printers, when a printer is taking up one job at a time, actually when we are giving the jobs, we can give n number of print commands at a time. But those commands are not taken up by the printer, but they are spooled. Spooled means they are put in a memory buffer area and they are provided or they are taken up by the printer one by one. Another important factor other than spooling is buffering. Buffering means that the data is kept in the memory buffer area before it is sent to the device or to the application from the device. So, both these activities of spooling and buffering are also taken up by the operating system. Now, the next function of the operating system is protection and security. Now, security means securing all components of the computer system, that is securing the hardware, securing the programs and the data and all the physical resources of the computer system. Of course, the purview of the physical resources to an extent is beyond. The physical security of the system is not a purview of the operating system, but yes, the operating system ensures the security of all its other components. So, security means that the devices, they are available to be used, the information is available to be used in a consistent manner. So, it prevents, when we are talking about security, we mean that the operating system will prevent any unauthorized access. It will make sure that the user accounts are created, user authentication is done, access rights are well defined. Access rights means that a user is allowed to access only that part of the files or the data which he or she is entitled to. Security of software, data and physical resources is also done. Then encryption is carried out by the operating system. Encryption means saving the data, the passwords and other confidential information in a form which is not directly readable by any other person or any other system or software. Data backup is another important function which is carried on by the operating system, in which the backup of the data is taken at frequent intervals. The operating system provides the interface to the user to define how to take a backup, what is the frequency of the backup, what are the critical areas for which the backup needs to be maintained and how regularly the backup is to be taken. In case of shared systems, the data which is shared on a network or on a local network is also defined by the operating system. Whether which files and folders a user can share, which they cannot share, all these are managed and controlled by the operating system. So, it ensures that the correct and authenticated user gets full access to the information which is available to his or her according to his or her privileges or rights. Now, the next important function is the user interface. We all know that the main job of a computer operating system is to make the device or the machine convenient to use. For this, the operating system provides two types of user interfaces. One is the command line interface and the other is the graphical user interface, which is commonly known as GUI. The command line interface, which we have seen in case of DOS or disk operating system, where all activities of the computer are specified in the form of typed commands. So, all commands are to be typed by the user. In case of graphical user interface, the desktop or the main screen of the computer has a large number of graphical options or graphical images, which are point and click operations can be done with the help of mouse, and a lot of typing effort by the user is minimized. So, the computer becomes really user friendly, and this user friendliness or ease of access is provided by the operating system to the users. So, friends, we have discussed about the various functions of an operating system in detail. Next we discuss is the storage structure, because we need to understand the different components of a system, of a computer system, to see that what storage structure are like. So, the main storage area or the main memory, which is only a large storage media that the CPU can access directly. This is the random access memory, which is called so because any data item can be accessed through it in the same amount of time. The main memory or the random access memory is typically a volatile memory. Then we have the secondary storage memory, which is the extension of the main memory. That is, it is the hard disk. We have seen that portion of the secondary storage area acts as a virtual memory also. Then we have the hard disks, which are rigid metal or glass platters which are covered with magnetic recording material. Now, the disk surface is logically divided into tracks, and tracks are divided into sectors. The disk controller determines the logical interaction between the device or the disk and the computer. Besides the hard disk, nowadays a new technology which is becoming very popular is solid state disks, which are non-volatile and they are much faster than the disk. So, when we are talking about storage hierarchy, we understand the hierarchy in terms of access time and storage capacity. Access time means the amount of time which is required or which is lapsed between the time a request is made by the user and the response is given by the memory. The data is sent back by the memory. So, the total time taken from the time of the request to the time the data reaches the user is known as the access time. So, storage system organized in hierarchy depending on speed, cost and volatility. Then another important aspect is caching. Caching means copying information into faster storage system. Like main memory can be viewed as a cache for secondary storage. And device driver, that is for each device controller there is a device driver to manage the input output. It provides uniform interface between the controller and the kernel. So, we say that a hierarchy is created in which the fastest memory and the smallest in capacity is kept at the highest end, whereas the memory which is non-volatile, which has high access time and high capacity, is kept at the lowest end of the pyramid. We can see that the top of the pyramid represents the registers, which is the smallest in size and the fastest. These are, we all know, these are the working memory of the CPU. They are a part of the CPU itself. Then we have the cache memory. We will see what is the function of the cache memory, but it is basically to cover the speed mismatch between the main memory and the CPU. Then we have the main memory, which is called the RAM. Then we have the other solid state disk memories, which are newer evolving technologies. Then of course is the hard disk, the optical disk, and then we have the magnetic tapes. So, the magnetic tapes which are used, they are basically the slowest of all memory storage devices and they are the least costly, whereas the registers which are fastest and smallest in capacity have the highest cost. Therefore, a hierarchical structure is created and different types of memories are used in combination to give the user the maximum speed, the maximum storage capacity at the minimum cost. The basic purpose of the operating system is to provide a faster access, large storage capacity to the computer system. Therefore, the operating system will manage all these different types of memories so as to increase the throughput of the computer system. Now, we were talking about an important topic called caching. So, caching basically means transferring data from a slower to a faster storage device temporarily. So, it is an important principle which is performed at many levels in a computer system, in hardware, in operating system as well as in software. So, data is copied from a slow area to a fast area. So, the faster storage is known as cache. So, when data is accessed, the faster area is accessed first, after which if the data is found, if the information is present there, it is known as a cache hit and the data is picked up from there. If the information, it is used directly from the cache, if data is not there in the cache, it is missing, then it is known as a cache miss and data is brought into the cache memory. So, cache is smaller than the storage being cached. This is an important point to remember because it is faster, it is more expensive. Therefore, the cache is a small memory. Cache management is an important design problem in case of computers, operating system, and the size and cache replacement policy is also governed by the operating system which is utilizing the memory. Then there are also some mechanisms for direct memory access structures. Direct memory access structures are used for high speed input output devices which are able to transmit information at close to memory speeds. Device controller transfers blocks of data from buffer storage directly to the main memory without CPU intervention. Only one interrupt is generated per block rather than one interrupt per byte. So, direct memory access structures are used only for very fast devices which do not require CPU's intervention for the transfer of data. Next, we have to start with the evolution of operating systems. So, evolution of operating systems from simple batch operating system or batch processing to what we see today. Now, the operating systems have evolved in various ways in the form of increasing the throughput to the number of users which can access the computer system, to the number of tasks which a computer system can run, to the amount of time which a operating system requires to respond to a particular user's request, and how an operating system is also used on a distributed environment where more than one computer is used and the programs are stored there. Now, in case of batch operating system or batch processing, it is same type of job or a batch with similar needs together and execute at a time. The operating system at this time, this is an old system which we are talking about, it was simple and its major task was to transfer control from one job to the next. The job was submitted to the computer operator in form of punched cards. At some time later, the output appeared. The operating system was always resident in the memory. Common input devices were card readers and tape drives. So, we can see in this diagram that in case of a batch operating system, the operating system and the user program area both resided in the memory at the same time. The user did not interact with the computer system, but it prepared a job comprising of the program, the data and some control information. So, those punched cards were put into the system at frequent intervals of time as defined by the system managers, and the operating system would then execute the whole process in the form of a batch. This type of systems or this type of operating systems work well in case of systems like payroll, where the task is to be run at a regular interval of time, say for example a 1 month's time. But with the evolving times, this sort of system could not work because the requirements of the computers, they became more intrinsic. The number of users which are accessing the computer at the same time increased. More so, even if a single user is accessing the computer system, the number of programs which are being run by the system by the user have increased manyfold. Therefore, the batch operating systems had to be replaced with other high-end operating systems which involved something like a multi-programming operating system. So, multi-programming operating system means that a single user will be accessing the operating system at one given time, but a number of programs will be run by the same user. Another important type of operating systems which are used now are multiprocessor operating systems. Multiprocessor operating systems require multiple processors which run the same task, or they can run different tasks. So, this increases the throughput to a great extent, and these computers are extremely fast computers because more than one processor work, and they are also known as parallel processing systems. Therefore, we will continue on this, on the different other types of operating system in the following lectures. Thank you for being a part of this. Thank you.
With this note, thank you, ma'am. Thank you so very much. Dear friends, if you have any queries, then do write to us at info.cec@nic.in. Your feedbacks as well as your suggestions are welcome. We would be meeting again soon. Till then, take care. Goodbye. Thank you, ma'am. Thank you once again.